Okay, so we're going to take a look at what we call one-to-one functions. So in this example right here, we can see map the domain -2, 0, and 2 using each of these functions. So in the first function, you can see f of x here is equal to 2 times x. So if I take -2, -2 times 2 goes to -4. 2 times 0 goes to 0, and then 2 times 2 goes to +4. So there's the domain on the left, the range on the right, which is the outputs. And now if we look at this x squared function over here, if I substitute in -2 squared becomes +4, 0 squared goes to 0, and then 2 times 2 also goes to 4 here. So you can see here is what is fundamentally different between these two functions in the how the elements of this domain get mapped to the elements of the range. And you can see here in g of x, both -2 and 2 map to 4. So you can see there are both functions here, but what's a little bit different here is that -2 and 2 map to 4. So what we're going to talk about here are one-to-one functions, okay? Now this is a mathematical definition of a one-to-one functions, is where if x1 and x2 are not the same number, then the outputs are also not the same, okay? In other words, different inputs always give different outputs. So let's take a look at some tables first here. So first, let's look at this function here. If I were to draw this, I've got the domain and now I've got the range here. And right away, if I have 4, I know 4 goes to 2, and then 4 goes to -2. So right away, we can see that that is not even a function, right? For the 4 maps to 2 and -2, so that's 2 outputs for 1 input. That's not even a function. Then if I go ahead and look at this function right here for number 2, you can see here what I'm looking at here is I've got all different elements in the domain, right? And then if I look at the range here, -2 will go to 1, -1 goes to 0, 0 also goes to 1, and then 1 goes to 2. So you can see that that is a function, except it's not one-to-one because -2 and 0 both go to this output number 1 here. In example number 4 over here, you can see the same thing again here, right? We've got -2 maps to 9, and then -2 also maps to 10. So that's not even a function. And you can see very clearly here, 1 goes to 2, 2 goes to 4, 3 goes to 8, and 4 goes to 16. That is a function, and it is one-to-one because different inputs give different outputs. Okay? So how does that look on a graph? We're going to see how this looks on a graph here. Circle the 2 graphs at above that are functions. First of all, we know that number 1 is a function. Every input gives us 1 and only 1 output. Right here, we can see that this is not a function, right? If I choose this input, I've got 1, 2, 3, 4 different outputs. It fails a vertical line test, so that's not even a function. Same thing here with a circle, right? If I choose this input, we're going to get 1, 2 outputs. It fails a vertical line test. That's not a function, okay? So we can also see that that linear one is a function. For every input, we get exactly 1 output. Now, of these 2 graphs that we circle, which one is a one-to-one function? And you can see that number 4, the linear, is a one-to-one function. Okay? Now, how do we know here? So if I look at this one, what happens here is the output of, let's say this is an output of 2. Right, so if I have this and then this input, they both give an output of 2. So what we kind of use here is a horizontal line test will help us determine whether or not a function is one-to-one. Right, so this is not one-to-one because there are outputs that are the same, right? This output here is the same as this output. Even though they're different inputs, the outputs are the same, okay? So that makes it not a one-to-one function, which gives us the horizontal line test, okay? So now, which of the functions represent a one-to-one function? Now, this, for example, number one, look, it passes the horizontal line test. However, it's not a function because I draw a vertical line, and you can see that there's two outputs for an input. Okay. Number two, definitely a function. However, if I draw a horizontal line, we're going to have the same outputs here for different inputs. Okay. Horizontal line test right here also fails, right? There's an output here, there's an output here. That's the same output. Even though the inputs are different, even though it is a function, it is not a one-to-one. And very clearly here, this is a function because it passes the vertical line test, and also a one-to-one function because it passes the horizontal line test. And the last one we want to check out is what happens when we're given a function. For example, d of x is equal to the absolute value of x minus 5. So if I go ahead and plot this in my calculator, and then I go look at the table, what we can do here is to determine why this is not a one-to-one function. So for example, if I make a table here, I've got an x and then I've got d of x. If I look in my table here, you can see here if I choose 2, 3, 4, 5, 6, okay, the outputs are going to be 3, 2, 1, 0, 1. And you can see at 2 points, 4 goes to 1. Whoops, 4 goes to 1. And also 6 goes to 1. All right, so if you look at the graph of this function, you can tell here it doesn't pass the horizontal line test, and you can see that it is not a one-to-one function because there are the same outputs for different inputs, right? On the mapping notation, what that would look like, you can see very clearly if we did some mapping notation, which is really a great way to kind of visualize functions here. If I had 4, 5, 6 in my domain, 4 would go to 1, 5 would go to 0, and 6 would also go to 1, which makes it not a one-to-one function, okay? All right, y'all, good luck.